So for Module 3 of Lecture 4, we'll look at the basics of user interfacing within MATLAB. So the first thing that we want to do when we talk about user interfacing within any programming language is have an ability to actually gather input from the user. And in MATLAB, that's accomplished using the built-in input function. And if we'll notice, the base syntax form of the input function is shown here. We need to pass as an input to the input function a prompt, which is a string kind of providing instructions to the user as to what they should do. And then the user will enter their information on the command line and hit enter. And that value, which is entered, will be stored in a variable x. And the data type used for x will depend upon the actual value entered by the end user. Now, one of the confusing things about the input function in MATLAB is users actually can enter names of variables. So remember that names of variables generally are going to be kind of look like words, for lack of a better term. So if we want them to actually enter strings, like if we're doing something like grabbing their name from the command line, we'll need to use a particularly modified form of the input function. Specifically, we'll need to pass in a second argument, which is a string just corresponding to s, which is telling MATLAB that basically we're allowing the user to enter a literal string. It doesn't necessarily need to interpret what they enter and try to execute it. So this might not make sense, but say you had a variable named name in the workspace and the user entered name. We want MATLAB to know whether it should actually kind of execute that variable name, and store the value of name in x, or whether it should actually store that text. So long story short, if you expect that someone would enter a text-based input, you will want to use the second form that's shown here of the input command, where we have that second argument to say, hey, it's okay to enter a string. When we want to display information actually to the command line, we can use the DISP function in MATLAB. DSIP will take its DISP. I forget what I just said there. I pronounced it definitely wrong. The display function, DISP, will take as input any variable in the MATLAB workspace. In addition, we can actually, if we just want to pass in a string to the display function, it will display something, that string, directly out on the command line. So just like everything, I kind of want to get you in the habit of not memorizing syntax, but rather being able to use help files in order to see how to write code. So let's try to write a script that will prompt the user to enter a value between 1 and 10. We want to take that input and square it. And then let's display the squared value back to the user along with an accompanying message describing the result. So I have MATLAB online here. I'll open up a new script. And I will do what I was asked to do. The first thing I will do is prompt the user to enter a value, easy for me, between 1 and 10. And if you remember, the way that we do that is we use the input function. I will call the variable in which we will store the input from the user as just user input camel case. And we will ask them to please enter a value between 1 and 10. One thing that I haven't said in too much detail yet, when I'm entering these strings, I'm only using a single quotation. You can use double quotation as well, and there's utility for using each, particularly when there's like an apostrophe in the string that you're trying to store. You basically want to use whatever delimiter that's not included in your string. So if you have an apostrophe in there, use the double quotes. If you have double quotes in there, use the single quotes. And there's tricks that you can do if you're working with strings a lot. They're things that you remember. If it's not, it's something that you look up when you need. So we prompted the user to enter a value between 1 and 10. And it turns out there's a way that we can improve this. But the only way you would know is to actually play with it and go through. So let's take the squared user input, and let's square it. So since I referred to, I've defined the variable user input to be the value that the user enters. I will take that and I will square that, and I'll define a new variable, squared input, and then I will display that to the screen using the DISP function. So there we go. So let's execute. Let's first save this, and let's say this is our display demo. And let's run it. Let's see what happens. So we're successfully asked to enter a value between 1 and 10 here on the command window. Say I entered 4. Looks good. And if you notice, it is correctly displaying the squared value 16 to me. The question is, how do we go about actually adding some text in there to say something like, hey, your value squared is 16? So the one thing I wanted to kind of emphasize to you here is you want to get comfortable actually using these hyperlinks and digging into the actual help files. And whenever I work with this, I just go right down and I see, hey, where is there an example that corresponds to what I'm trying to do? So here they're showing how you can display a vector, how you can display a string. Okay, that's not what I want to do. I want to display a combination of a string and an actual value. So let's kind of scroll down, and I'll cheat a little bit because I've been long on my videos. I want to, in general, make them short. Let's look at what's going on in here. Display multiple variables on the same line. If you notice, they have a literal string Alice, actual double, variable age as 12, and they're kind of creating this new vector that's basically putting a bunch of stuff together. So name is a string, will be literally is a string, this year is a string, and they're taking some function num2string and passing in age, which was a double. And what they're actually doing here is taking the double variable and creating it to a string. And what's going on here is they're creating a new string, which is a concatenation of these 4 strings. So we could probably take that approach. We could probably use something like this. So usually what I'll do whenever I think there's something useful for me is I'll copy it over actually to my script, and I'll just paste it right in here. And I'm going to put, rather than call this name, that's not very meaningful, I'll call it message. And you notice MATLAB is trying to tell me, hey, you probably want to change all references to that variable to message. You had the word name in there, now it's message. So if I hit Shift Enter, you notice it will automatically update all the occurrences of the previous variable name to message. And rather than, I'm not interested in the name Alice, I want to tell the user what their squared value is. So I'll say your squared value is, and did I? No, I didn't. Good. I have my squared input here. So what I need to do is kind of concatenate a message consisting of your squared value is, so that's in message. And then I don't need, my string is relatively simple versus the one that they were concatenating together. I just need to put together my message, your squared value is, with my number. And since I can only put variables together of the same type, I will need to change my number, squared input in this case, not age, to a string. So one of the things you might wonder is, well, how can I tell, I don't want to break stuff. How can I make sure that this is right before I actually display? Well, one thing you could do is actually comment out your display line and then take the semicolon away from the line of code in which you're actually forming your new string as the concatenation of the two. And then you can run this and just make sure, so I'm entering my value, I know this part works. If you notice, it effectively is forming the string that I want to display. Your squared value is, and you can debate, should you have a semicolon in there, shouldn't you? Probably looks better without one. So here I've kind of used the semicolon to my advantage in order to display and make sure I have the right string that I want. But in order to be consistent with good practices, I will rename the string variable that I want to display to display, and then I will pass that into the display function. So you could argue that, hey, you could just leave the semicolon off and concatenate those 2 strings, but that's not necessarily good programming practice, since by definition, to display a message on the command line, we want to use the display function. We will take that string and pass it into the display function. And notice now if I run this, even with all output suppressed, if I enter 5, for example, it helps to actually type in on the command line, I will be told that my squared value is 25. So think about the holes in this program. Well, beyond kind of the comments that I make about having good programming practices of using a comment block in the top and having comments distributed throughout in order to tell what you're doing, another thing that we don't have is any kind of validation to actually make sure that the user entered an input between 1 and 10. So for example, if I rerun this and I type in -2, I'm going to get squared value of 4. So that's syntactically correct, but it's not semantically correct. I wouldn't want this to run if someone enters a negative value. In addition, what would happen if I don't know, just didn't enter anything, just hit enter? It still just tells me if I enter nothing, the squared value of that is nothing. So I might want to add some error checking. In order to do that, we need to kind of introduce the idea of conditional program execution. We'll need to talk about if statements, and then the concept of conditional execution of if statements will lead us into the various looping type structures. And that's how we're actually going to wrap up the second portion of the module. So if you looked at the schedule for this week, you'll notice that part 1 is posted here on Monday evening, and then we'll be posting the remainder of module 4 on Wednesday. The homework for this week will only cover the first part of module 4 and the last part of module 3 that we didn't have questions on last week, but this is kind of meant to be a foreshadow into getting to conditional control, which probably will be, I think it will be, the last material that's actually on your exam for next week. We'll cover a little more material. We'll probably end up hitting that spreadsheet content, but the only thing on the exam will basically be everything through completed module 4. So hope you enjoyed this part. Hopefully it's getting a little more interesting. Really, to make this more fun, we need to build these out into actual applications that you can actually deploy either on the desktop or on the web. And then I think you'll like it a little bit more. But in order to do that, we need some additional tricks up our sleeve, particularly the ideas of conditional control structures, which we'll look at next.